Hi, today what I'm going to do is show you how to program a 18-megabit microcontroller using the TL866. In this example, what I want you to do is I've got a small program here which will take about 5 kilobytes. Now rather than using 18MEGA328, I can use an 18MEGA8 instead. So in order to do that, what we need to do is open your Arduino software like we've got here and load your program. Now there's a few captures with using a different microcontroller. I'm intending to run this one at 8 MHz with the internal clock. If your program uses any timers, they won't work correctly because obviously the clock speed's different. So that's something you gotta watch out for. But in this example, it's just a simple program which gets some data from a HX711 load cell and writes it to a 7-segment display via SPI, so there's no timers used. So currently it's compiled for an Arduino Uno, so what you'll need to do is change it to 18MEGA8. Okay, that I'm using 18MEGA8L, which is the same chip, it's just a lower power one that runs at a maximum of 8 MHz rather than 16. Once you load your chip, you just want to make sure it compiles, which it does. It's using 5,158 kilobytes. You want then want to go to tools. Set your options here. In this case, like I said, I'm using internal 8 MHz. So you check that there to make sure it's set to internal 8 MHz. And that'll make sure the code compiles correctly with the correct CPU speed. I'm not using an input loader in this instance, so I'll untick that. EEPROM doesn't really matter. Brown light level detection, set the default 2.7 volts. So that's okay, so we need to go now, go to Sketch, export compile binary. You then browse to your Arduino project folder. Go into your project folder. Then if you're using any plugins, so officially the Arduino software doesn't support the bare chips. There's a couple of libraries you can load. Using the board manager file. I'm just going to show you that now. So what you'll need to do is this new version of the software, you want to go to Tools. And it decides to load up Manage Libraries. That'll bring you to this. Then you can go to this here, the Boards Manager folder. And then you can select different boards. Like I've got here, which is supported. And what you're looking for is down here somewhere. You've got the Sanguine there. That's one of the things you could use to support it. Other ones is the MIDI car library, that's what I'm thinking of. So you want to install this here. That gives you support for the other chips. So this is the library I'm using, but yours might be different. But anyway, that's besides the point. Now you've created the .hex file, you need to go into this build folder. And you've got your MIDI core AVR right, and then you're looking for the .hex file. So then just confirm that it's actually today's date, which it is. Then you want to open your MIDI core, go there. You then want to open your program software. Now I've already done this, so I'll just start doing a video of it. Now, when you load your chip on here, it will set the fuse bits to the default settings, which basically resets the chip back to factory defaults, which is 1 MHz internal clock. If you do that without setting the fuse bits, it won't work. So in this case, what I've done here is set the fuse bits for 8 MHz internal clock, and you want to be looking here for your fuse bits here. You want bit bytes or want it to be 0xFF. When you change these, you'll see that changes. So if it's all unselected, it'll be 0xFF. Your high bytes want to be 0xD9. So you boot SZ1 on, boot SZ0 on, or ticked an SPI enable on. Otherwise you won't get a program if you turn that option off. And this sets your brownout level and your clock divisions. So in this case it's set for 8 megahertz internal clock. So once you've done that, you just load your hex file. Go to the board folder, but there's a hex file, open it. Okay, right, there we go. As soon as you do that, it's reset the fuse bits back to the default settings. Now, like I say, don't flash them, otherwise your board won't work. So I'm going to change that back to 8 megahertz now, which was brownout level and level. Which one was it there? Right, okay, so you tick these options here. This sets it back to 8 megahertz internal clock. And then simply go back to the flash. And then click program. That will then write the hex file to the chip and also set the fuses. Right, okay. That. Alright, the next thing now, finally, is to program an Arduino bootloader onto the ATMEGA8L. Okay, right. So to program an Arduino bootloader onto the bare chip, I mean, say in my example, I got a box full of second-hand microcontrollers. Some of them had fuse bits set, some of them didn't. So what I did, I reset them all to the factory defaults. So by, first of all, you select the chip over here, and we'll have to load that, go to your config. That'll set the default fuse bits. So you then want to flash that to the chip by just going to the program. You probably have to select the bootloader first. So if you want like program it, so what we'll do now is we'll go to load, browse to your Arduino folder in your C drive. Arduino, we found it hardware, Arduino area, firmwares, bootloaders, you use OptiBoot, and then you want to be looking for OptiBoot, ATMEGA8L.hex. Open that. Okay, that. It will then reset all the fuse bits to the default settings. You'll then want to program the chip. That will reset the chip back to the default settings. Then the next step is to set the fuse bits correctly, which will reset it to 16 megahertz CPU clock with an external crystal. So you want to make sure all the lock bits are off. And then I will just quickly show you now which is the correct options to tick on here. Right, these are the fuse bits you need to tick to set it 16 megahertz clock with an external crystal, and enable it so that you can program it by your SPI. So you need to make sure that non-volt bits are set, VOD level set to 1, SPI enable is on, boot reset 0 is on, and none of these are selected. And you then program it back to the chip again. That will then write the hex file and set the bits, fuse bits. Your fuse bits here should say 0xFF, DE, FD, and FF. And that's pretty much it. You can then either put the Arduino chip, we can actually put the ATMEGA8L chip in an Arduino and program it that way, or you can just export your hex file like I did with the ATMEGA8L and write that to the chip directly without the need to put it in an Arduino to program it. And that's pretty much how you do that. I hope you find that useful. Thanks for watching.